Okay, Assalamualaikum warahmatullahi wabarakatuh. Our last part for session 1. Okay, this slide is for the last
in
part,
this
part
part
4 for our
we
session.
will take
1. A look to an overview of reciprocating engines. So actually, reciprocating engines is an engine that use one or more pistons in order to convert pressure into rotational motion. So they use the reciprocating, which is up and down, up and down, up and down motion of the pistons to translate this energy. So now, can we take a look to this picture, okay? To this diagram, to this picture. So uh, we will show you the parts of the reciprocating engine. We have a cylinder, okay? We have cylinder here. We have intake valve first, intake valve, and then we have exhaust valve, and then we have spark plug, and then we have um, crankcase, we have crankshaft, and then we have a connecting rod and pistons. Okay, this figure shows the nomenclature for reciprocating engines. So normally we have bore, clearance volume, top dead center, TDC, strokes, bottom dead center, the reciprocating motion up and down. We have piston, cylinder wall, spark plug or fuel injector, the valve, the rotary motion, and crank mechanisms. So normally, we didn't use the term as a diameter of the cylinder. We use the nomenclature as a bore. Bore. Bore is actually the diameter of the cylinder. We have another intake valve is the way of the air or air fuel mixture drawn into the cylinder, and stroke, yeah, it's not height of the cylinder, but we use stroke as the distance between TDC and BDC. TDC is top dead center and bottom dead center, that the piston can travel in one direction. Remember, one direction only. And we have exhaust valve, the way the combustion product are expelled from the cylinder. We also have a spark plug to ignite the air and fuel mixture in the cylinder to create the explosion. We normally use these terms, the nomenclature for the reciprocating engines. The main nomenclature that we will use is bore, top dead center, the stroke, the bottom dead center, intake valve, and exhaust valve. So the top dead center is the position of the piston when it forms the smallest volume in the cylinder, because it is in the top. So our volume is the smallest in the cylinder. While the opposite, the bottom dead center, is the position of the piston when it forms the largest volume in the cylinder. So it goes down and it will give you the highest volume. In this figure, we can see the volume. The volume at top dead center and the bottom dead center. So A, we call it as a displacement volume or swept volume. So the volume displaced by the piston as it moves from top dead center to bottom dead center. And clearance volume is the minimum formed in the cylinder when the piston at the top dead center. From there we know we can have our compression ratio. Yeah, when it goes up and down, up and down, up and down, we know that when we go up, it will be they will compress. So the compression ratio R, the ratio of maximum to the minimum clearance volume in the cylinder, where RV, volume compression ratio, is actually the swept volume plus the clearance volume over the clearance volume, which means that the volume in the maximum and over the volume in the minimum. So we can have the volume at bottom dead center over the volume of top dead center. And we also have to know the mean effective pressure, MEP. What is the meaning of the mean effective pressure? Why we need to know mean effective pressure? Because we already know we can calculate the efficiency of the system. Then why need we know about the mean effective pressure? This is because the mean effective pressure can be used as a parameter to compare, to compare the performance of reciprocating engine of the equal size. When the engine is equal, then we can compare their performance by using mean effective pressure, MEP. So we know that MEP is actually the parameter used to compare the performance, and the engine with a large value of MEP will deliver more network per cycle and thus will perform better. So the equation for the formula for mean effective pressure is work net over the difference of maximum volume and minimum volume, as shown in this figure. Okay, it's already the end of the session 1 in chapter 2. So can't you try this problem? What is the Carnot efficiency of a heat engine operating between the temperatures of 673 Kelvin and 400 Kelvin? Now, please submit above problem solution to your respective lecture. Till then, bye. Assalamualaikum. And we finish our session 1 with doa. Bismillahirrahmanirrahim. Allahumma inni istaudi'uka ma 'allamtani fardudhu ilayya 'inda hajati wa la tansanihi ya rabbal alamin. Artinya, ya Allah, sesungguhnya aku titipkan kepadamu apa yang telah engkau ajarkan kepadaku, maka kembalikanlah dia kepadaku di saat aku memerlukannya. Janganlah engkau buat aku lupa kepadanya, wahai Allah, Tuhan pemelihara alam. Moga-moga kita diberikan kefahaman, okey? Bye. Assalamualaikum.